In 2019, the best solar scientists on Earth made a prediction about the Sun. They studied decades of data, ran their models, and told the world what our star would do next. They were confident. They were careful. And the Sun did almost the exact opposite. So completely that years later, they still can't fully explain why. This is the story of how our own star broke the forecast, and why that should get your attention more than any headline about a distant black hole. Start with what makes this strange. The Sun looks like the most reliable thing in the sky. It rises, it sets, it burns. Boring even. But the Sun is not a steady lamp. It runs on a cycle. An 11-year heartbeat where its activity climbs to a violent peak and then falls quiet again. At the peak, the surface erupts. Dark spots crawl across its face, magnetic storms tear off its surface, and blasts of radiation and charged particles come screaming toward us at over 1,000,000 miles an hour. At the quiet end, the Sun goes calm, its face nearly blank. Scientists have tracked this rhythm for over 250 years, counting the dark blemishes we call sunspots as the simplest measure of how angry our star is at any given moment. And those spots are stranger than they look. A sunspot isn't a hole or a stain. It's a place where the Sun's magnetic field has become so intensely knotted that it chokes off the flow of heat rising from below, leaving a patch that's cooler and therefore darker than everything around it. Some are bigger than the entire Earth. They are the visible bruises of the magnetic chaos happening beneath the surface, and when there are many of them, it means the Sun's magnetic field is tangled and loaded with energy. Energy that has to go somewhere. Count the spots, and you're really counting how close the Sun is to erupting. It's the oldest trick in the book, and for 2.5 centuries it's been our window into the star's temper. And because they've watched it for so long, they thought they had it figured out. That's where the story really begins. In December of 2019, an official panel, convened by NASA, NOAA, and an international space weather body, issued their forecast for the cycle just beginning. They called it Solar Cycle 25, the 25th since detailed records started. Their verdict was clear. This one would be weak. Roughly as weak as the cycle before it, which had been the feeblest in 100 years. They put a number on it. The peak, they said, would come around July of 2025, and the sunspot count would top out at about 115, a modest, sleepy maximum. Some scientists went further, whispering that the Sun might be sliding toward a decades-long slumber, a grand minimum, the kind of deep quiet that hadn't been seen in centuries. It was a careful prediction, built on real physics and a century of data, and almost immediately, the Sun began to make it look foolish. To understand why they expected weakness, you have to know what came just before. The previous cycle, Cycle 24, had been a genuine disappointment, the weakest in 100 years. Its peak had barely registered, and 2 weak cycles in a row can look like the start of a trend. Some researchers worried the Sun was winding down toward something historic, a grand minimum, a stretch of decades where the spots nearly vanish and the star falls into an unusual hush. The last time that happened, during a period known as the Maunder minimum in the 1600s, sunspots almost disappeared for around 70 years. So when the panel forecast another weak cycle, they weren't being lazy. They were reading a real and worrying pattern. The safe bet, the data-driven bet, was that the Sun would stay quiet, and maybe get quieter still. That is exactly the bet the Sun refused to take. By 2020 and 2021, just the first years of the new cycle, the numbers were already running hot, above what the panel had drawn on their charts. At first, it could be dismissed as noise. Cycles wobble. But the activity didn't settle down. It kept climbing, faster and higher than the forecast allowed. By early 2023, Cycle 25 had already grown stronger than the entire previous cycle had ever been. The scientists who had called for a sleepy Sun watched their own graph get left behind. Then it stopped being a quiet disagreement and became a spectacle. The sunspot count didn't just beat the prediction of 115, it blew past 150, then kept going, at times climbing above 200. Nearly double what the official panel had forecast. The peak didn't wait politely for July of 2025 either. The sun surged early, reaching heights in 2024 that were never supposed to happen for years. And this wasn't just a number on a chart. A more active sun means a more dangerous sun, and Cycle 25 started throwing punches. In May of 2024, the sun unleashed the strongest geomagnetic storm to hit Earth in over 20 years, a rare, top-tier event. For a few nights, something happened that most people alive had never seen. The aurora, the northern lights, normally locked to the freezing edges of the planet near the poles, spilled thousands of miles south. People saw the sky glow green and red over Mexico, over southern Europe, over the lower United States. Millions of people looked up and, for the first time in their lives, watched the sky catch fire. In colors it wasn't supposed to have where they lived. It was beautiful. It was also a warning. Because a few months later, in October of 2024, the sun fired off the single most powerful flare of the entire cycle. An X-class flare, the strongest category there is, and near the very top of that category. A burst of energy so large it's hard to picture. And here is the part that turns a pretty light show into something you should actually care about. When the sun erupts like this, it isn't just making auroras. It's hurling a wave of charged particles and radiation at the technological skin our whole civilization now lives inside. A strong enough solar storm can knock out satellites in orbit. The same satellites your GPS, your phone signal, your weather forecast, and global navigation all depend on. It can cause radio blackouts. It can push surges through power grids on the ground, tripping transformers, and, in the worst case, plunging entire regions into darkness. This isn't science fiction. We have a preview. Back in 1859, before we depended on any of this, a solar storm now called the Carrington Event struck a world wired only with telegraph lines. It was so intense that telegraph systems failed. Sparks jumped from the equipment, and some operators reported the wires glowing. Auroras were seen almost at the equator. If a storm that size hit today's planet, a planet threaded with satellites, power grids, and undersea cables, the damage could run into the trillions and knock out infrastructure for months. And the sun that just spent 2 years shattering our forecasts is the same sun that produced Carrington. So now we arrive at the real mystery, the honest one. The one that has nothing to do with disaster movies. Why were the scientists so wrong? The uncomfortable answer is that we still don't fully understand the engine driving all of this. Deep inside the sun, layers of superheated, electrically charged gas churn and rotate, generating a magnetic field of staggering complexity. This process, the solar dynamo, is what builds the sunspots, launches the flares, and sets the rhythm of the entire cycle. And despite everything we've learned, the dynamo remains one of the great unsolved problems in astrophysics. We can watch what the sun does. We can measure it in exquisite detail. But predicting it, truly predicting the strength of a cycle before it happens, has repeatedly humbled the people who try. Cycle 25 is just the latest proof that our best model of our own star is still incomplete. There are ideas about what the forecasters missed. Subtle features in the sun's magnetic field near the poles, the tilt of its spots, patterns that only reveal their importance in hindsight. But these are still being argued over. No one has a finished answer. What they have is a star that keeps refusing to follow the script, and a growing respect for how little boring actually applies to the thing that holds our solar system together. And that's the part worth sitting with. We tend to think of the sun as settled, a fixed point, the one thing in the sky we can count on. But it isn't fixed. It's a churning, unpredictable, magnetically violent star that our entire modern world now depends on, and that we still cannot fully forecast. Every satellite, every power grid, every navigation system on Earth is quietly betting that we can predict our star's moods well enough to see the big storms coming. Cycle 25 just reminded us that this bet is far from safe. The good news is that this failure is also how the science moves forward. Every time the sun breaks a prediction, it hands us a clue about what our model is missing. The scientists who got Cycle 25 wrong aren't embarrassed into silence. They're rebuilding their forecasts with the new data, sharpening the tools, getting ready for the next cycle. The sun surprised us, and being surprised is exactly what tells us where to look next. So the next time you step outside and feel that ordinary sunlight on your face, remember what's really up there. Not a steady lamp, a restless, unpredictable star in the middle of a peak we didn't see coming. Still capable of reaching across 93 million miles of empty space to touch the machines that run your life. And still holding on to secrets that our very best science hasn't cracked. If the idea that our own star just outran every prediction the experts made, and that we still can't fully explain why, changed how you look at the sun, you already know what the like button is for. And if you want to keep going, the story of what would happen to Earth if the sun ever fired a Carrington-level storm straight at us is waiting on the channel.